Okay, lesson 12, unit 6 of Algebra 2 is called tangent. So our goal is let's learn more about tangent. Okay, what do you notice? What do you wonder? So I think before we can do notice and wonder, we need to maybe fill this table in a little bit. So as I go through it and look at it, I notice that they give us the values in decimal form. So we could get these values from the unit circle. Like obviously, let's do pi over 6. The sine of pi over 6 we should know is 1/2, and the cosine of pi over 6 is radical 3 over 2. And if I type in the square root of 3 divided by 2, I'm going to get 0.87. So that's where they get the numbers from, okay? You could get them off the unit circle, convert them to decimals, or you could, I guess, get them from just typing in sine of pi over 6 and cosine of pi over 6 and all those angles into your calculator. You just got to make sure that you're in radian mode before you do that. But those are the values there in decimal form. We're going to put them in decimal form because they'll be easier to graph. My tangent, I have to divide the sine by the cosine. Or again, you should know a lot of those from the unit circle. So I'm going to go ahead and fill those in here. This is undefined because if I do -1 divided by 0, it's undefined. You can't divide by 0. All right, go ahead, and the next one's -1.74. I do -0.87 divided by 0.5. That gives me -1.74. Go ahead and finish these up here. I get -0.57. 0 divided by 1 is 0. 1.74. No, wait, that's wrong. I get 0.57. Sorry, I did it wrong. This is going to be 1.74, and then this is going to be undefined again. Okay, so notice and wonder. So let's come up with some notice. Let's come up with some wonder. Okay, so I would say I notice that I don't do a full circle. I only do half a circle. Your unit circle here, negative pi over 2, pi over 2, that's just this section right there. I don't do any of these values over here. I don't do any of that. So I'm going to definitely notice right away that we do not complete a whole circle. I'm going to wonder, why does the table stop? Okay, what else do I notice? I notice that we have undefined values. I notice that we have values greater than 1 and also less than -1. On your sine and cosine curve, you don't have anything greater than 1 or less than -1. Okay, you can look at your table here. You see that they're all between 1 and -1. I wonder what the graph looks like. What else? I wonder, is it periodic? It looks like it's periodic, but we don't know. It hasn't fully repeated yet. I'm going to notice that we have same values, only opposite though. So a lot of stuff there. We'll get more in depth with that as we go on. Okay, so I'm going to go ahead. I'm going to complete the table here. That's all I'm going to do for this. So I'm going to go ahead, fill this in. And the first part we already kind of did. So I'm just going to copy that from the other slide. Again, I'm just dividing sine over cosine, or I could type in the angles into my calculator, or I could get them off the unit circle, turn them into decimals. All right, so there's the first part, complete the table. The second part, how are the values of tangent theta like the values of cosine theta and sine of theta? How are they different? Well, we kind of already answered some of that. So alike, different. Okay, how are they different? Well, greater than 1 and less than -1. We have undefined values. Alike, it's periodic. We can see that it's repeating. So if I look here and draw lines here, looks like I repeat here, and then I start again, I start undefined. But the only difference here, I will say, is that this length from here to here, is pi radians, not 2 pi. So that's going to be a different thing on here. Period length is pi radians. Okay, if you remember from the other lessons, when we graphed a sine and cosine curve, a full period, if I had a sine curve, it would look like this. A full period length was 2 pi, if you remember. And a cosine curve would start up here, and it would be something like that, okay? And that would be the same thing. A full cycle was 2 pi on the sine and cosine curve. The green one's the cosine, and the black graph there is the sine curve. Okay, so there's a couple things that are different. How are they alike? Another thing that's alike, we could say that the values come from the unit circle. And we could say also that values come from the unit circle, and we could say, what was I going to say? Oh, we have the same angles for each graph. Okay, same angles with theta. All right. So let's go on to the next thing. Before we graph this and take a look at what a tangent graph looks like, all right, we have a couple questions here. So before we graph tangent theta, let's figure out some things that must be true. Explain why the graph of tangent theta has a vertical asymptote at x equals pi over 2. That should be theta equals pi over 2. I don't like how they change the variables. They use theta here and then they change it to x. So let's keep that as theta equals pi over 2. So obviously, I'm going to just say here, tangent theta equals sine of theta divided by cosine of theta. And when cosine of theta equals 0 at pi over 2 equals theta, we can divide by 0 because it's undefined. Division by 0 . All right, so if it's undefined, we get an asymptote. Now you might remember from earlier when we were doing this stuff, and I'm just going to write this down here. We had a function maybe like this, 3 over x minus 2. Okay, that's called a rational function. And we knew that x cannot equal 2 because if I plug 2 in here for x, I would get 0 in the denominator. So what ended up happening was on your graph at x equals 2, we had an asymptote right there. Okay, we put a dotted line and we know that we can't have an x value on our graph at x equals 2. So kind of the same thing over here. We're going to have asymptotes at pi over 2. All right. Does the graph tangent theta have other vertical asymptotes? Well, if I go back to my table here, what I notice is at pi over 2, negative pi over 2, 3 pi over 2, I notice these are equally spaced by pi radians. Okay, if I add 1 pi to pi over 2, I'm going to get 3 pi over 2. And if I subtract 1 pi from pi over 2, I'm going to get negative pi over 2. So what ends up happening over here is these are equally spaced. If I keep adding pi, okay, my graph's going to go on forever. There are other asymptotes in both directions. Okay, so this way I'd have to subtract pi to go from there, and so forth. Okay, so obviously there are many other asymptotes because it's periodic and it's going to go on forever. For which values of theta is the tangent of theta 0? For which values is it 1? So go back to your chart again. Tangent theta equals 0. Let's see here. 0, pi. And if you go down, it's also at 3 pi as well. Or sorry, 2 pi. It looks like those are spaced pi units apart. So I would say, so it was 0, pi, 2 pi. Obviously, you're going to keep adding pi, and your graph goes on forever. And then in this direction, we subtract pi. And then the last one here, where is it equal to 1? We don't have any spots on our table that it equals 1. So go ahead and take a look at your unit circle, and you're going to see that at pi over 4, the tangent's 1. And then 5 pi over 4. And you notice those are pi units apart, okay, because pi over 4 plus pi is going to be 5 pi over 4. Okay, 1/4 plus 1 is 5/4. So that's going to be 9 pi over 4, 13 pi over 4, and so forth. If I go this way, I subtract pi, it's negative 3 pi over 4, and so forth, okay? So let's put it all together and take a look at the graph. Okay, so here's my graph. I'm going to put my asymptotes on there first. So I have asymptotes at negative pi over 2, pi over 2, 3 pi over 2. I'm probably going to have one here at negative 3 pi over 2. I didn't do that on my chart, but there it is. And then the next thing I'm going to do is I'm going to put all my pi over 3 and pi over 6 multiples on there. So if I split this angle up here, this is going to be pi over 6. This is going to be pi over 3. This is going to be 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3. That would be 5 pi over 3, and this would be 11 pi over 3. This would be negative pi over 6, and this would be negative pi over 3. And then I need to go up to 1 and 2, negative 1, negative 2. And then what I'm going to do is I'm going to plot my points from my table. So I'm going to go back to my table, and I'm going to plot the points. So hopefully you wrote them down. You paused the video, wrote them in your notebook. At negative pi over 3, we're at like negative 1.74. Negative pi over 6, we're at negative 0.5 something. 0 is at 0. Pi over 6 is at 0.5 something. This is 1.74. So what you end up getting is a graph that looks like that. All right? And we get that little curved graph. And I could plot all my other points from my table, but I already know it's periodic. I know it's going to repeat, so I could just kind of, copy and paste everything over here. Just kind of transfer it. And it's going to keep repeating. And my graph stops at 2 pi, but it would, would keep going like that if I had more graphs there. Oops. And then over here, same idea. Just going to do a rough sketch. And it looks like that. Keeps repeating. All right, and it's a little different than the sine and cosine curve because it can go bigger than 1 and less than negative 1. Okay, whereas the sine and cosine curve was contained in between those two values. All right, so here's all 3 graphs on one graph. So we've kind of already answered all this. When does the tangent value take 0? When's it not defined? Yeah, we've already answered all these questions in the last couple slides. So the last thing here is the value of tangent 3 pi over 4 is negative 1. You go to your unit circle, 3 pi over 4 is right here, and it's negative radical 2 over 2, comma, radical 2 over 2. If you divide the sine by cosine, we get negative 1, okay? So what we learned today is it repeats every pi radians. So if I subtract pi, or subtract 2 pi, or add 2 pi, it's going to be the same value. So what we should know today is that this is the same as this, so it's going to equal negative 1. Okay. Now, if you don't believe me, 3 pi over 4 minus pi is negative pi over 4. You can type that into your calculator, or you could look at it on the unit circle. That would be negative pi over 4 would be right here. So it's going to be negative 1. And same thing here, I'm adding multiples of pi. So this is going to be the same as up here. So this is going to also equal negative 1 as well.